Hello students, welcome back to Sampurna Academy YouTube channel, and I am coming with one topic, very interesting topic, that is transportation. And my name is Dr. Suman Kumar. Yes, this is for both science and commerce students for PUC 2 level, that is especially Karnataka syllabus, PU board syllabus. So I hope you are ready to learn this transportation problem. Yes, it is very important for examination point of view. Not only for that, I am sure if you become engineer or if you will be a part of any business which consists of transportation, then you come across this kind of concept. So for those who will be working in transportation business or you are going to become engineers, yes, this is a right topic for you all to understand. And for the exam sake, you may expect 8 marks in your exam, that to PU board exam of PUC second year level. So without wasting much time, let me start this transportation problem. So in your textbook, it's a 8 model and the B part of 8 model. Okay. So now let me make you understand why we call this as transportation problem. Okay. So problem because you need to solve being an engineer or a commerce student. So what is that problem first of all? Okay. Let me explain. So in this chapter, first I'll start with example and definition, then problems, then I go with the theory. So students, are you ready? Let us start with one example. Okay, here it is in front of you, a simple common example where you will understand end of this example where and how to use this transportation concept. Okay, so the problem, as I said, it is a transportation problem. In short term it is called as TP. Okay, so what is that? With some problem, okay, that is example, right? I'll make you understand what is the meaning of transportation problem. So assume you are the owner of a business or you will be a part of a business where you have 3 manufacturers or 3 factories. Say, let us call it as 3 factories, and assume you are having 3 warehouses. So whatever you manufacture from these 3 factories, you are going to send those materials or a finished goods to the warehouse, right? That is your job. Now, what is the big deal in this? So I am going to make it so next step so difficult to analyze. So now listen carefully. Assume that this factory can manufacture 500 units. So it may be anything, whether it is a motorcycle, car, or it may be any apparel. Okay, you may take it as a t-shirts, whatever. So now for your convenience, I am going to take it as, say, bicycles. Okay, so let us restrict our example for bicycles. So this factory is manufacturing 500 bicycle. Assume that this factory is manufacturing 250 bicycles. Similarly, the third factory, assume you manufacture 1000 bicycles. Okay, and also one more thing you need to assume, let this factory be in Bangalore, let this factory be in Mysore, and this factory be Mangalore. Okay, so in 3 different places, simple. Now these are the 3 warehouses in different places. Say one is in Delhi, other one is Mumbai, and one more is Chennai. Now your job, whatever you manufacture, you need to send those finished goods to this warehouse. That is your challenge. Okay, assuming that this warehouse is having a demand, okay, of 200 units or 200 bicycles, right? And one more 700 bicycles. And the last one, let us assume 350 bicycle it needs. That means the demand. requirements, I can say requirements. This warehouse required 350 units and this warehouse requires 700 and this warehouse 200. Warehouse or showroom you can say. So let us call it this as showrooms. So these three showrooms, 350, 700 or 200 units is required. Okay. Now, next one more input for you. Assume to transport 1 unit from this factory to this warehouse, the transportation cost is 5 rupees per unit. Try to understand, you are manufacturing 500, okay. This showroom requires 350 units. To send one bicycle, okay, from here to this place, the cost of transportation is 5 rupees. Okay. Similarly, from this factory to another warehouse, assume the transportation cost per unit is 10 rupees. Similarly, 15 rupees. Okay, this is from first factory. I hope you understand it. Now, let us continue. So now, from second factory to the first warehouse, 10 rupees transportation cost per unit, remember. Second, 15 rupees and 20 rupees. Similarly, for the third, okay, that is 5 rupees, then 10 rupees per unit, then 5 rupees per unit. I hope you are understanding the challenge. Hence, this is a problem for you, because the first constraint is you need to send all whatever you manufactured. Okay. The second challenge to meet whatever the demands you have. And the third point is, obviously, if you are a good manager, you need to send all whatever you manufacture to the wherever it is required with a minimum cost. That is very important. Now, the question is, with all these three, okay, the biggest question mark is how you can reduce your transportation cost. Okay, this is a problem. Right? So, if you learn this subject or a concept, okay, you can solve this, math, right? That means you will be able to find out the minimum cost, what is required to meet whatever the requirements and whatever you have a supply, okay. Whatever you manufacture, you will send to the warehouse or a showroom in such a way that, okay, the cost of transportation should be minimum. So you need to find out the best possible route where you are going to reduce the transportation cost. Hence, this is a challenge. So my dear students, if you learn this, you will be able to find out the basic feasible solution where you can send all of whatever you have manufacture to the required with a minimum cost. Okay. So let us continue. What is TP? What is transportation problem? Transportation problem is considered as a special type of LPP whose objective is to determine the quantities of units to be transported from various origins to the different destination at a minimum cost. This is very important. I hope you understood the definition of transportation problem. Now let us move forward. So here, steps in solving TP. TP means transportation problem. So first step is finding the initial basic feasible solution, the first thing. And the second one is optimizing or optimization of initial basic feasible solution. Anyhow, for our syllabus, we only have the first step, that is finding the initial basic feasible solution. In your higher studies, you are going to learn how to optimize the initial basic feasible solution. Okay, so let us not worry. So we are going to restrict ourselves to for the first step, that is finding the initial basic feasible solution. Next, the methods of finding initial basic feasible solution. The methods are, actually there are three. Again, for our syllabus, we have only two. The first one is NWCR. The second one is MMM method. The third one is VAM. So let me tell what is NWCR. That is Northwest Corner Rule. NWCR, please write down, my dear students. NWCR means Northwest Corner Rule. And the second one is matrix minima method. The matrix minima method. And the third one, which is not there for our syllabus, and you have Ogle's approximation method. You are going to study this method in your higher studies, either in your degree or post graduation. Those who are pursuing your CA, yes, of course, you are going to learn this in your CA syllabus. Okay, so there are 3 methods, but for our syllabus, only 2 methods. That is NWCR, Northwest Corner Rule, and matrix minima method. Okay, so now let us take one problem for solution, right? So first I'll read out the question and explain what is given. Then let us solve this problem. Okay, so the problem is the solution obtained by NWCR for the following TP? Is TP generate? Okay, they are asking us to solve by using the first method, that is NWCR, that is Northwest Corner Rule method. We have to solve this TP. That is, we have to find out initial basic feasible solution, and also we have to check whether the given whatever we get solution is that TP is having degenerate. I'm going to tell what do you mean by degenerate and how to find that. So first step is to solve the problem. Okay, let me first explain this problem, then we can solve the problem. So the problem consists of one matrix, okay, one table, which says that, okay, to and from, and the availability, and then requirement. So when you add up these 3, you will get 210. Similarly, when you add up these 3, you will get 210. When you add up this column, the last column and the last row, when you get the same total, then we say, okay, that as a balanced TP. That is balanced transportation problem. I repeat, what do you mean by balanced transportation problem? So the transportation problem in which the last column, that is availability, the sum of availability and the sum of requirement are equal, then we say the given TP is balanced. First, our job is to check whether the given TP is balanced or not. Normally, in our syllabus, they give balanced. So forget about giving a problem from unbalanced TP, right? So anyhow, by default, the requirements and availability sum will be same. Okay. Now, let me explain what this each cell. Okay. So from A, if they need to send any raw material or any unit to X, means they incur 8 rupees per unit cost, transportation cost. Similarly, what is the meaning of 7? If they want to transport 1 unit of from A to Y, the cost incurred is 7 rupees. What do you mean by this 9? If they want to send any unit from B to Z, the transportation cost is 9 rupees per unit. So how to solve? By using this NWCR method, that is Northwest Corner Rule. Let me explain now. So very simple. First of all, Northwest Corner Rule. This is north and this is west, south and this is east. Northwest, that means you have to remember this direction, northwest. Okay, so please remember this Northwest Corner Rule. That means northwest corner. For this table, northwest means, let me show you, this is the northwest. okay, corner. So we have to start allocating for this corner. While allocating the resource, you need to check out that column. So what is the requirement? That is 50. Similarly, you have to check out with the row, what is the availability? 60. Requirement is 50 and availability is 60. That means whichever the smaller from these two, that is 60 and 50, you need to allocate that. So in this two, the smaller one is 50, hence I am allocating here. Okay. So first of all, this method is northwest corner rule. For this, table, okay, for this table, right, northwest is the cell. Hence, I started allocation there. So how to allocate? Very simple. Smaller between 50 and 60. Okay, 50 is the smaller, hence allocate that. When 50 already allocated, that means this becomes 0. And what about this? From 60 you are sending 50. Means remaining is how much? 10. I hope you are understanding, my dear students. So as this becomes 0, what you need to do? Just you need to cancel that. That is, you need to cancel this. Very simple. Okay. Then continue. So what next? Remaining, that is 1, 2, 3, 4, 5, 6 cells. Again you need to use this formula, that is northwest concept. So this is the northwest corner. Okay. For this now we need to allocate. Now for this 10 is remaining and the requirement is 80. Among these 10 and 80, which is smaller? 10 is a smaller, hence allocate here 10. So this becomes 0. From this you are allocating 10, means this becomes 70. As this becomes 0, you need to cancel that. That is, you need to cancel this. Very simple. Now, left out is 8, 9 and 3, 5. Again same concept, northwest rule. Okay, this is a northwest. For this you need to check out 70. For this 70, both are same. Hence you need to go with 70 only. So this becomes 0 and this also becomes 0. Now, your job is to cancel two things. One is 0, this one, and this is also 0, hence cancel this. Right? Remaining is 5. Am I right? Remaining is 5, and you can check out 80. This is also 80. See, at the last, you should remain with the same number. That means you are in a right direction towards the solution. So 80, 80, hence allocate this 80 here. So this becomes 0 and also this becomes 0. Yes, cancellation. So as 0 becomes this cancel, this also you need to cancel. Now all rows and columns are cancelled. This is the first part of the solution. Now allocated. Okay, what you need to do? Next step, simple. You need to make 3 columns. One is the cost and allocation, number of units. Number of units. Okay, then cost per unit, then total cost. 3 columns you need to make. Number of units allocated, which are in the small box, try to understand. Okay, so that is 50, and the cost per unit of transportation, that is 8, and also you need to write down the route A from A to X. So I am writing here A to X. A to X, 50 units are allocated, okay, and 8 rupees per unit, right? Then you need to multiply these two, write down here. Now this got over. The next step, A to Y, A to Y, right? So how many units you allocated? 10. Cost per unit is 7. Then this becomes 70. Then you come for this. From B to Y. From B to Y. What is the units allocated? 70. Per cost, per unit cost, 80. Right? $560. Right? Next, the last one, because there are 4 allocations. 4 allocations should be there here. The last one is C to Z. C to Z. Okay. Now the number of units, 80. Right. Then cost per unit, 5. So you have to multiply. Again, this becomes 400. Yes. So this also becomes 400. There was a mistake. Now you need to calculate the total. The total will be 1430. That is, total is 1430, 1430. Okay. So this is the initial basic feasible solution. That means this is a total cost you need to incur to send all the whatever you have available to the required destination, and this will be the initial cost. That is rupees 1430. If you do up to this, yes, you will get 5 marks. So next, let us solve one more problem similar to this. So this is northwest corner rule. In next, we are going to solve the problem by using matrix minima method. So now let me take one more problem, but this problem is by using MMM method. It is called as matrix minima method, and one more name for this is least cost method. Either they can ask it as a least cost method or MMM method, that is matrix minima method. Okay, let me solve this. So first of all, we need to highlight the main cells area. This is the area. Among this, which is the minimum, because we are using matrix minima method. That is, in the given matrix, the cost which is minimum among the given, we need to select that cell first. So in this, marked area, okay, the minimum value is 8. Okay, hence we need to select this. So this one we need to select. Okay, so for this cell, for this column, the minimum is 8, and for this, requirement is 8, and for this supply is 18. Among these two, the minimum is 8. So this becomes 0, and this becomes 10. As this becomes 0, we know that we need to cancel that. So I am cancelling this. Okay. Now, what next? Again, in the remaining cells, which is the minimum? We have to find out. So among this 19, 50, 10, 70, 40, 60, 40, 70 and 20, the minimum is 10. Hence, we need to allocate for the cell. Okay. So for this, 7 and 14, which is minimum? 7. Hence, you need to allocate 7. So this becomes 0. Among 14, if you allocate 7, so remaining is 7. So as this becomes 0, so whenever any row or column becomes 0, we have to cancel. Remember this. So I am cancelling this. Right? Now, the left out cells, that is 70, 40, 60, 40, 70, 20. Among this, the minimum is 20. Hence, we need to allocate for this 7 we have, and here 10. Among these two, 7 is a minimum, hence you allocate 7. So this becomes 0, this becomes 3, because from 10 you are allocating 7. As this becomes 0, you have to cancel this. So I am repeating, whenever any rows or columns become 0, you have to cancel. Then we have to check out the minimum value among the remaining. That is, remaining cells are 70, 40, 40 again, and 70. Now minimum is 40. You have 2 here. Okay. So either you can allocate here or you can allocate for this cell. So choice is yours. I am going to allocate for this 40. So here 7 is there, and for row wise 3 is there. Among 7 and 3, the minimum value is 3, hence allocate 3 here. So this becomes 0 and this becomes 4. As this becomes 0, our job is to cancel this. Very, very simple. Now, remaining, that is 70 and 40. Again, among these two, which is a minimum? 40 is a minimum, hence you need to allocate here. So for allocation, so 5 and 9, among these two, 9 and 5, minimum is 5, allocation will be 5, this becomes 0. From 9, if you allocate 5, the remaining is 4. As this becomes 0, our job is to cancel this. Right? Now we left with only one, that is 70. Everything is got cancelled, right? 70. 4 here, again in this 4. So remember, you need to get last both same. So here 4 and 4. Hence, write down here. So this becomes 0. This becomes also 0. Hence, now our job is to cancel. So everything is cancelled now. What next? Our job is to write down the 4 columns. One is root. The second one is number of units. Then the cost per unit and total cost. TC means total cost. Now, you have to find the allocations here. The first allocation is A to D4. Hence, you need to write down A to D4. Right? Number of units allocated is 7. Then the cost is 10. So total cost is 70. That is, you need to multiply these two. The second row, B and D1. So B, D1. Okay. Number of units allocated is 4. The cost is 70. Hence, total cost is 280. Right? Next allocation is B to D3. B to D3. I hope you are understanding. B to D3. The number of units allocated is 5. The cost is 40. So the total cost will be 200. You have to multiply these two and write down. Right? Next is C to D1. C to D1. Okay. Number of units allocated is 3. Cost is 40. And the total cost will be 120. Then C to D2. C to D2. Right? What is the number of units? 8. The cost is also 8. The total cost will be 64. The last one, C to D4. Right? Number of units is 7. The cost is 20. Right? And the total cost is 140. Then you need to find out total cost. So the total cost will be 874. If we do this much, yes, so 5 marks is yours. So our job is to find out the total cost, right? So for this problem, the cost of transportation, that is initial basic feasible solution, is 874, and the method used is matrix minima method, and it is also called as least cost method, right? So we learned two types of problem, that is NWCR and matrix minima method. So if you get any doubt, you can pause the video and watch it and you can learn it. So the mantra is very simple, right? So you already know you have to practice. The mantra is to practice the problem. Then you will be very perfect. I hope you learned both the methods, my dear student, that is NWCR and matrix minima method from this video. If you liked this video, kindly share and also subscribe. Okay, we'll meet again with different topics in next video. So happy learning, my dear students. Thank you.